This other version is very similar. So we're going to pull out a cosine. So it's going to be cosine squared of 5x sine squared of 5x times cosine of x dx. So then my u sub now is going to be sine of 5x. And then du is going to be 5 cosine of 5x dx. So then du over 5 is cosine of x dx. So this is du over 5. So the integral becomes 1/5 integral du cosine squared of 5x is u cosine squared is 1 minus u squared. 1 minus u squared times, this should have been a squared in here, times u squared, because u is sine of x. So if you do this, you'll get 1/5 integral of u squared du plus 1/5 integral of u to the 4th du. And this will give you 1/5 u to the 3rd over 3 plus 1/5 u to the 5th over 5. And then going back to what u is, you'll get 1 over 15 sine cubed of 5x plus 1 over 25. Is it plus? See, I make algebra mistakes too. This one is a minus here, so this will be minus, and this will be minus. So this is minus 1 over 25 sine to the 5th of 5x plus c. So this should be the answer for the first one. And then the second one, again, I didn't mean for this one to be giving you troubles, but so you see that it's kind of complicated, sine of ln of x, so let u be ln of x. So therefore du is 1 over x dx. So now when you try to write it, you get that the integral, let's call this integral I, is integral of sine of u. But then for dx, what are you going to write for dx? Well, you got to solve for dx in here. So dx is going to give you x times du. But you need it all in terms of u. You can't have x's and u's. You have to either have just x's or just u's. So how do I get x? X is what in terms of u? Well, I just go from here. If u equals ln of x, then x is going to be e to the u equals e to the ln of x, which gives me that x, because e to the ln of x is x, equals e to the u. So this is what you're going to plug in for x. And once you do that, you'll see that dx equals, instead of x, you put e to the u du. So again, you'll have sine of u instead of dx times e to the u du. And now this one you do IBP. And here you're going to put e to the u because that's easy to take derivative of. And for your dv, you'll put sine of u. So you take the derivative, and that's e to the u. And then you take the integral of sine, which is negative cosine. And then you do it one more time, e to the u. Integral of negative cosine is going to be negative sine of u. And now you notice that for this last step, you're going to have e to the u times sine of u, which is exactly your I. So you stop here. To stop here, I'm going to have this one with plus, this one with minus, and then the integral of that with plus as well. Okay, so then your I becomes negative e to the u cosine of u from this one, and then a negative times another negative will give you a positive e to the u sine of u, and then a minus integral of e to the u sine of u. But you had to notice that this one equals I. So then when you add I to both sides, you'll get 2i equals negative e, well, u is ln of x, so negative e to the ln of x, or you can think that e to the u is x, so we can straight put that e to the u is x, cosine of u is ln of x, and then plus x sine of ln of x. So then just I is going to be negative 1/2 x cosine of ln of x minus x sine ln of x plus your c. That's just one version of the answer. Alright, so this should be the answer for that one.